Let's go. Good morning. All right. We're going to be continuing to work on Copilot. Just a quick recap. What Copilot is. It's going to be a EVE application. It is an EVE application for visualizing EVE data. Exploring EVE data. So the idea here, let's just jump into it. The idea is we give you all the raw data you could possibly ever want, and then we combine that with this tool called data blocks for the front end, which lets you do all kinds of things like sort, filter, merge, slice, whatever you could possibly think of to transform that data and then visualize it. And if we don't give you what you need, we give you this custom code block. So you can do whatever you want. You can write your own code and build the tools that you need to play EVE. Spreadsheets online. Let's go. Yeah, check out DataBox. There's a little demo link up here. It takes you to something like this. You can add blocks. Let's see here. Let's add a time series. All right. Boom. Link things up like that. Set your columns. Okay, look at this. Now we're seeing the number of UFO sightings, because that's the raw data that we're looking at. We're seeing the number of UFO sightings per year. Peaked out sometime late 2000s, and now nobody cares. All right, so first things first. Yesterday we set up our project here in our IDE. This is a Phoenix server. Phoenix, if you don't know, this isn't documentation. Phoenix can be found at phoenixframework.com. Something like that. Nope, not that. Maybe if I type better. Phoenix Framework. Nah. Where is it? Oh, .org. Phoenixframework.org. Don't go to phoenixframework.com. All right. This is it. It's a Linux HTTP server. Pretty sure I mentioned this yesterday. I'm pretty sure it was like one of the most loved HTTP servers in JetBrains report from 2022. State of developer ecosystem, something. Yeah, every year JetBrains puts out one of these, and they're always like super interesting, I think. Right? Yeah. Let's see if we can find it real quick. I'm getting sidetracked, but I love looking at data. That's what this project's all about. So we don't mind. Languages. All right. Maybe I'm lying. Help you. I can't remember technologies. Beloved. Favorite. Most favorite programming languages are Kotlin, Alright, let's follow this favorite thing. Favorite programming languages. How far down is Elixir? Well, apparently far enough down to just be part of other. That's cool. Can't believe JavaScript's up there. Mention most often. Ah, okay, that's why. That's not a very good measurement of favorite. Well, anyway. This is not actually the report I was thinking of. I'll find it. We'll go over it tomorrow. So, today we're going to be looking at the Swagger documentation here. We're going to be trying to call latest. Is that the versionless one? Yeah, okay. We're going to be trying to call some of these endpoints down here in EVE Universe. And my goal is actually just to be able to get some of this data. Because even just to do that, even just to, for example, call this endpoint, we need to be authenticated. So we need to do a couple things. We need to build a client to call the API. We need to make sure that we are able to properly authenticate so that we get the data. From there, if we get that far, we'll figure out how to save the data to our SQL server so that we can actually do some interesting things with it. But there's a lot of data here, and it's relatively like all related, right? So let's just say we even just are looking at a type, right? So first of all, type, most generic name ever. What they're talking about are item types. I believe, mostly, anyways. So, even if we just look at that, you know, you got capacity description, dogma stuff, but then graphic ID. So that's going to be a relationship to some other data. Group ID. So the icon ID. All right. Well, then the type ID. That's this type ID, so that's not a relationship, but we've got like 3 relationships here, right? I spent a little bit of time searching through this, and honestly, some of the most like what I'll call like the root entities, ones that don't have parent relationships that they belong to, would be things like categories. For some reason, categories has a list of groups so that you can see the groups inside of a category. The way that they seem to relate these things is there's almost 2 levels. So there's categories, and then there's groups inside of categories, which it's like, okay, I mean, technically you could have just had groups inside of groups, and then you could have had a tree structure, but I don't mind this either, because this way you have just 2 levels of organization or grouping, and it's a little bit being able to have like bake in that assumption into certain things makes life a little bit easier sometimes. Quick note, hopefully the music is not so loud. I rewatched my stream from yesterday and it was blowing my eardrums out, so turned it down today. We'll see how well the music is equalized. Hopefully it just hovers around -40 at the peak and you can hear me okay. All right, just gonna quick text my wife to tell her that I'm online. If I have 0 viewers, we'll know whose fault it is. Definitely not my own. I'm not boring. Copy. All right, let me just shoot her a text real quick. I'm online. Smiley. All right, cool. Let's get started. So first thing we're gonna do is we're gonna set up a little client, and the way that I like to, like when I'm in this sort of rapid prototyping phase, I like to not build up here in the lib, right? Well, because that's, you know, a little bit hard to run the code. A lot of times it's nice to just build down here in the tests, because you haven't this like excellent test runner just baked in. When we do like mix test, for example, that runs all these little script files. And that's great because we can just put our code that we're trying to run in a test file, and then it will get run by our test runner. Cool. So first thing we're going to do is create our test directory, because you can see here there's a couple of tests for Copilot Web. We're going to be putting our API client in Copilot. So got to create a Copilot directory. You'll notice that the test directory and the lib directory kind of mirror each other. So if we go inside of Copilot Web, you're going to find controllers, and then you're going to find, you know, here is air HTML ex, and so you have air HTML test exs. The S means it's a script file. It doesn't get compiled at compile time. It gets sort of compiled at runtime. All right. So anyways, you mirror things like that. And so we're going to, how do I want to structure this? I mean, someday probably we'll want a behavior. If you don't know, a behavior in Elixir is kind of like an interface in a lot of other languages. It basically says what functions are available in a given module and roughly how many parameters each one takes and what their types are. Technically, Elixir is a loosely, like, not a statically typed language, and so the types are more for documentation purposes. But the reason why behaviors are important and having an interface is important is because later on when you're writing unit tests, you want to be able to write unit tests that call your API without call the underlying API, the easy API, without actually making HTTP requests to EVE Online servers. That would not be good. First of all, your tests would run really slowly, and they probably wouldn't actually even work. So you want to mock them out, and for that, there's a library called mocks. We'll get into all this later, but you need a behavior because mocks needs an interface to mock. Okay. So, anyways, we'll figure out the directory structure later. For right now, I'm just going to go ahead and create a directory called easy, and I'm going to create a file in here called client. All right. So here we go. We're gonna have a module here, Copilot easy client. Again, this follows the directory structure rule. Copilot easy client. Sweet. And going to want for now a function that I think calls items. I would say we should call categories again because those are like at the root level, but that's just so boring. So I don't want to do that. I don't care about categories. I want types. I want to get some item types in here. At the end of the day, the way that I visualize using this the most is for market data. So we got to start with the market items. And I think this will give us all kinds of items, not even just market items. We'll be able to know if they're market items based on... Alright, so types just gives us, as far as I can tell, a list of IDs, but then we take each one of those IDs and get the type details. And we can come down here and we can see, alright, so there's group IDs, and then there's market group IDs. And this only exists for types that can be put on the market. And so I'm going to go ahead and assume that if this market group ID is null, it's not a market item. If it's not null, it's a market item. And that's how you tell. All right, so let's try to go ahead and get these. So I'm not going to call these market types. Let's just call them get types. I absolutely hate that name, but here's the question. Do we set up a little sub module for each one of these groupings? I think we do. I think we're gonna make one for... I'm changing my mind already. Let's go. That's okay. This is not gonna be called easy. I don't like that name already. Maybe it should be called easy. I will call that easy, but we're not calling this client. We're gonna call this universe. And the reason is that we're gonna have, we already have these high level groupings, which is nice. And I don't want to worry about having unique function names within every, like across the entire API. So if I create a module just for universe, each one of the, I can come up with function names for each one of these endpoints that is unique, even if it is similar to, for example, a function name in a different thing. Let's say, just as an example, under the market section here, we had a function called get groups. I mean, that would be potentially confusing if we had a function already called get groups under the universe section. So by having separate modules for each, I'm going to call it domain here, we can avoid that. We can avoid that confusion. So we've got easy, universe, and then we're going to have a function called get types. Cool. All right. Oh, cool. I've got one viewer. Hello, wife. All right. Get types. And you can see that GitHub Copilot is already generating some code here for us, which is sort of amazing and giving me a good idea already. So they think that this should be Copilot easy get universe slash types, and I sort of agree with them, which implies that we should have a file here called easy, and this one should implement a lot of like our basic reusable code for all endpoints, right? So we can have a get function in here that is going to handle the authentication for any get endpoint that we want to call across the entire API. So that's pretty cool. Like, look at this. Look at this. You're so good, GitHub Copilot. I don't know why you keep putting those 3 dots at the end, though. That's a little weird. That's a little weird. All right, we're going to need an HTTP client, though. And for that, we're going to use something called Tesla. It's an HTTP client, loosely based on Faraday. All right, cool. So let's installation, optional but recommended adapter, Hackney. Do we do Hackney? We already have Finch. All right, well, we'll add Tesla there. We already have Jason. And, let's check out Hackney real quick. Duplicate tab. Oh. This is a HTTP client in Erlang. Why is this the recommended adapter? I don't think so. All right. What other adapters can we use? Let's go to the adapter section. Using adapter other than HVC, recommend the dependencies to mix when using the Hackney adapter. You know, I'm most familiar with Finch. Mint has also been recommended to me. Finch built on top of Mint. I don't know why Hackney is the recommended one. I think we're gonna go with Finch. Yeah, alright. I don't want to spend too much time on this. The nice thing about Tesla is if you change your name, or if you change your mind later about which adapter you want to use, it's really not the end of the world. So we already have Finch in our project. That just came when we installed Phoenix, or when we set up the project and generated it. So we already have that, and then we're just going to need to plop this little configuration line into our config down here. Config, and we'll put it here. Why not? All right. And the adapter, so this is, I don't know that we have any options that we want to pass to it necessarily. Maybe we'll just leave it like this for now. In order to use Finch, you must start it, provide a name, for example, in your supervisor tree. Ah, okay. So that's the way to do the Finch adapter, I guess. We must already have Finch in our supervisor tree. I wonder if the music's too loud. Is the music too loud? Alright. Let's see. Gotta check out our application here. Alright, so we already have Finch, and its name is Copilot Finch. So we're good there. We just need to set that in our config like that. Okay. Great. Other Finch options include the pull timeout, the receive timeout. We'll ignore those for now. Alright. We've got Tesla set up. Let's go back to the main page. And we're going to look at an example client. Alright, music is good. Cool. Thank you. Alright. So here we're looking at an example client of GitHub, which is using Tesla and then a couple of middlewares, and we've got some functions here. This is similar to what we're going to be building. Now, I'm just gonna actually, this one we don't care about. I'm gonna grab this and come back here. Now, if we just use Tesla and add some middlewares, actually most of these middlewares are pretty good. the token we'll have to come back to. The token we'll have to come back to, but you'll notice that if we look at the documentation here, they have a function called user repos, and it's just calling a get function. Where does that get function come from? It comes from this use Tesla. So if you're not familiar with Elixir, use is kind of like require in a sense. It actually is like way cooler than that. So it can give you access to functions and things like get, and it also can sort of extend the language in a way by providing you with macros. So that's where these plug keywords come from. That's not part of Elixir. That's something that's a macro that got injected into this module when we said use Tesla. Elixir is like such a beautiful and powerful language for that reason. But if you look at the modules, Tesla. So if we look at the Tesla module, you come down here to functions. It has a get here. And this is the get 3 version, which is takes the client, the URL, and the options. But if you're using Tesla as a middleware, it's going to inject a get 1 and a get 2 version that just takes the path or the path and some options. Like in this case, we're passing along query options. That's mostly what we're gonna use. So that's cool. And then we don't need that. Great. So here we've got authorization, and we will need the authorization header. I was looking through how to authorize this API, and they use OAuth 2. And so if we click here, sending authenticated requests, you authenticate with the authorization header, and then you send along bearer with your access token, right? So in this case, our access token would be XYZ. You don't need to capitalize this. I just like to. It's a thing. All right. And our base URL is not going to be api.github.com. It is going to be, let's see, what is our base URL? The Swagger docs should have this in there. Where is our base URL? Well, it doesn't say there. Possibly it's under meta. Man, I kind of need the raw Swagger docs. I don't know how to view it in here. Get latest Swagger spec. Try it out. All right, I'm pretty sure then. Yeah, well, it didn't like. Oh, I did like that. Okay. Base path, latest, consumes, definitions. Let's look through here. Here's all the paths. Swagger 2.0. The scopes. Themes. Models. No. Alright, well, here it is. It doesn't really matter. This is going to be our base URL. Let's grab that. Interesting that it looks like you can call this with no authentication. Is that true? It is true. Alright, sick. So if that's the case, we'll see how much we can do without any authentication. That's going to make our lives a little easier. We'll just comment out that middleware there then. And we're going to come over here to our universe module. And we're going to call Copilot easy.get universe/types. I don't want this trailing slash here. Doesn't really matter, but I don't like it. Okay, so let's set up a little test now. And we're going to need to copy the same directory structure that we have there. So we're going to call easy/universe test.exs. And now we need to set up our test file. It's not going to be a con case. We'll come back to that in a second. But it's going to be Copilot, not Copilot Web. Easy. Universe test. Nope, don't need that. And then we'll just call our test get types. We're not going to assert anything. We're simply going to call our universe function here, get types. So Copilot easy universe dot get types. All right. Let's see if we have any other. I don't necessarily need a case here. I do need it to know that it's an X unit though. And I can't remember how to set that up. Well, it shouldn't hurt that it is a con case either way. So we'll just leave it for now. Oops. Hello. My keyboard is in all caps and I don't remember how to fix it. There we go. Got it. I have the Happy Hacker keyboard, by the way, and so it's like there's not just a caps lock button. I don't know how I hit that. All right, so mix test, and then we're gonna just test this one file. So test Copilot easy universe test. Okay, it's telling us that we don't have the Tesla package installed. We can fix that by doing mixsteps.get. That's correct because we added it down here, but we never installed it. So now let's try that again and see what happens. All right, we get a couple of warnings. Unused import bitwise. Well, that's not me. Application get env is discouraged. So these are all warnings from the Tesla middleware. But then we got an error, compilation error in University XE, undefined function, get types. There's no such import. Oh. This is the problem with trusting Copilot, GitHub Copilot, for defining things for you. They forgot to put the def keyword in front of that function. Okay, cool. So it apparently didn't blow up. We're just gonna output the response that we want to take a look at what we got. So we're piping into the debug function. The debug function is super cool because it does a lot of things for you. It tells you exactly where the function was called. It tells you which function ran, and it tells you what the response was. So we got an OK, a Tesla env, we got various headers, and a body, error not found. Well, that's not great. Let us see if we can fix that with the base URL. I have a feeling what's going on is the base URL is not this, it's this. That's what we saw. Whoa, scroll. Well, hold on. That's what we saw here. If you can see, our base URL was easyevetech.net/latest, and then /swagger.json. That was the URL for the endpoint. Let's give that another shot. Now, this is one thing that's interesting. It did say that this was okay, right? But it's a 404, so we do need to be a little careful. It acts, I mean, this isn't totally unprecedented. This is how lots of APIs work now with the advent of GraphQL, at least, because GraphQL, you post all your GraphQL queries and you get responses, and the response almost always is 200 unless it's a infrastructure level issue, like a networking issue or a load balancer, or like the service is down and you get a 503 or something like that. You always get like a 200 back, but you have to look inside the body to see if it was actually an error or not. So with Tesla, this is saying, okay, yes, we properly processed that request. There was nothing wrong at the application level, but you need to look inside and sort of look at the status to decide whether or not it was an error. You could also look at the body. In this case, the body is saying error not found, which is also useful. So you've got two different ways, but you need to look at the request to know if it was an error. You can't simply look at that. That okay here is telling us that Tesla did its job okay. Doesn't mean that you did your job okay. All right, so we got another okay. Headers. And this time we got a 200 status and a lot of binary data here in the body. So we're gonna need to process that. Now I'm surprised that the JSON middleware did not process it, because we are saying that the content type is application JSON. So we're gonna need to do a little bit of our own lifting to process this. Okay. Let's add a couple other helper functions here in our easy API, because we've got the middlewares. Let's look at the JSON middleware. Maybe we don't have that configured properly. Right, JSON. Yep, we've got that. We do not want keys as atoms. We do want to use the JSON engine. Not sure why I didn't decode that body for us automatically. A little weird. All right, that's okay. URL, headers. So we're gonna want something that processes our response and is able to look at the okay here and also the status, and sort of combine those two pieces of information to tell us if our request was good or not. And now it's going to be a little complicated because the EVE API doesn't just return 200s when things are okay. It also returns, let's look at the endpoint that we were just calling here. Types, right? Oh, maybe that wasn't binary data. Oh, I'm wrong. Types gives you a list of integers. That's the response type. Okay. I misread that. Okay, so that's an array of integers. The JSON middleware is working perfectly. Sorry, a little ADD here. But here, our responses can be a 200, which is a list of type IDs. It can also be a 304. How does the 304 work? Well, a 304 basically means that nothing changed. And the reason why you would use that is because potentially this is a lot of data, right? And let's see if we can even see how big this data is. Dun, 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 dun. There should be a content length. All right, yeah, so it's 5,554 bytes. Okay, that's a lot. That's some kilobytes, right? Now, it would be better if you could just say the data you already have. Let's say we've called this request once before, and we're like, all right, I called this request and I have this list of IDs. Did anything change? That's all you want to know. You just want to know if something changed or not. If something did change, you want the new list. If something didn't change, if the list you already have is still good, you just want a thumbs up. That's what 304 is. So you'll notice here that we have this E tag, this value here. That E tag is basically a way for us to say, look, we already have a list. Is it the same? And the C tag identifies the list that we have. So we should be able to do something like this. Okay. All right. I don't know why that is. Not properly. We can do that. Let's see here. Man, I always forget how to properly use this thing. Good thing the documentation is so good, right? Yeah. Okay. So we can send in keyword list just like that. And what are the options supposed to be? All right, headers. All right, so we need to send in. Can't just be headers like that. We need to go headers, and we'll see what this ends up being. I'm gonna guess that this is going to be not a keyword list, but instead, oh, it is. Okay, it's a keyword list of binary tuples. All right, that makes sense. All right, so e tag. There. So we're passing in headers. We're passing in this one header here, saying the e tag that we have. If we do make format, that should just fix it for me. The spacing. Let's go. All right, cool. Looks great. Now, that'll run all the tests, but it doesn't matter. Undefined function def in EasyEX8. Oh. Yeah. We'll get back to that. First, I want to test out this e tag thing. Alright, so now that we've included this e tag, we'll see if we, instead of getting a 200, we still got a 200. Okay, so possibly we are using this slightly wrong. Perhaps the e tag is just this portion. Nope. Still getting back the full 200. That's interesting. You can see that it's got the same e tag. It appears that this, oh, if none match, e tag from previous request. Okay, that's why. I'm silly. The header should not also be e tag. That's what we get in the response header. What we need to send to them is the if none match. Now, I'm really hoping that it's like this, that it's not this inner string here, because that's going to be super annoying to parse out. I have to basically take off this w/ prefix. So hopefully it's including the w/. There we go. We got a 304. And so here we see that the body is empty. They give us the 304, indicating that what we already had is still correct. Cool. That's beautiful. So there we go. We got our types. Let us We're not gonna obviously be able to hard code any tag in here. So for now, what I'm gonna do is take ops, which is gonna be an optional parameter. And if we're given them, we'll pass them in here. If not, we'll just default to empty options and pass nothing in. So if we test again, now we should get back our list of types, because we're no longer sending that a tag. All right, so it's a long list, and there's apparently a type with the ID of 0. Should we go see what it is? Make another function here called get type. It's going to take the type ID and again. Look at that. This time, EVE Copilot is smart. So basically what we're going to be doing here is we're making another GET request for universe types, and we're going to pass in the type ID. That is going to call this other endpoint here. No longer looking at that one. Now we're looking at this one. Get information on a type. So we should start to see the capacity, description, dogma, information, things like that, what group the type is in. So let's see what that is for type 0. All right, all we need to do is update our test. Let's actually make a new test. Get type. We're just going to pass in the number 0. I don't want to run this one, so I'm going to comment it out. This is what I was talking about before, by the way. Using the unit test system to just kind of quickly prototype. It's definitely a life hack. All right, so what do we have here? Well, this is hashtag system, I guess. That's what type 0 is. Okay, cool. Let's try a couple other ones. I noticed 6 was in the list. See what 6 is. See how far we have to go before we find an actual item in the game. All right, so this one is Sun G5 yellow. All right, a main sequence stellar body of a class that is often yellow or yellow-orange in hue, generating and emitting energy from the vast hydrogen fusion process within the heart of the star. Various numbers of planets of the terrestrial and gas giant types are found around these stars, and the habitable zone often contain one or more planets. That's what I love about EVE. Like, everything is so thought out. The mass, the packaged volume is 1. All right, well, I'll give them a pass on that. I suppose you can't package a sun. Published, false. I wonder what that means. So we can see that the group ID is 6. The type ID is 6. The volume of 1. Radius of 10,000 meters. I'm going to say that published maybe means published on the market. Let's pick a bigger number. So scrolling up here, 56,897. See what that is. 56,897. All right, a rapier has a control skin. So published true, and it has a market ID. So far, it seems that we have 2 ways, at least, of identifying if something is on the market. One is if it has a market group ID, and potentially if it's published. Let's see if it says in the documentation what published means. It doesn't. Cool. We'll have to figure that out as we just continue to explore this data. All right, so I think our first task is kind of done. We have an outline for how we're going to build up the client here. That's great. Now what we want to do is we want to get the types into our database. Let's see if we can do that. So I'm going to create first a domain in here called universe. I think what I'm going to do is, I'm going to just use their API to name our domains. So what I mean by a domain, by the way, is in an application, you will typically have distinct, like, you could probably categorize distinct responsibilities of your application. For example, one portion that many applications have is just user data, accounts, right? So maybe your domain there is accounts, and all of the code and actions that you do that are relevant to accounts can be organized into that domain. It's a way of saying that the responsibilities of managing accounts are distinct from, say, the responsibilities of, in our case here, like ingesting EVE data, right? Or let's say authentication. That's another one that's very common to lots and lots of applications. Authentication is a little bit different than managing accounts. Like creating a user is different than authenticating or authorizing a user. So maybe you have a domain called auth or security or something along those lines, which is responsible for verifying who a user is and what a user is able to do. That's a little bit different than creating a user and managing the data about that user, updating their profile information with their name, address, and so on. Like, so you might have two domains there. You might have accounts or users, and then a second domain that's called auth or security, something along those lines. And that separates the different responsibilities of your application. All right. Now, I might regret this later. A lot of times people will spend a lot of upfront planning on what domains their application is going to have, and that's not a bad use of time. Honestly, upfront planning sometimes can be, an ounce of planning is worth a pound of development time in some cases. But in this case, I'm just gonna quickly look at this and see, all right, EVE has already gone through and thought about how to categorize all the different data types here. I'm just gonna use their lead. I'm not gonna pretend like I know better how to organize this application. As far as I can tell, the application that we're building has essentially just a handful of responsibilities. One is data ingestion from the EVE API, storing that data, presenting the data to the front end, and then the front end is able to process the data. So in terms of what the back end is responsible for, it's ingesting the data and storing it. And now that is going to include at some point character data, such as the characters, market orders, their wallet information, their skills, their current location, things like that. And for that sort of character data, we will need some semblance of like users and accounts and security, auth, whatever, like those types of domains. We'll get to that. We'll cross that bridge when we get there. But for now, I'm just going to say that each one of these groups is a domain. So first thing we're going to do is just go through the universe domain and ingest the types information. Okay, so how do we ingest types information? Let's see if we can do this in 45 minutes. All right, well, we're going to need a couple things. We're going to need some commands, some events, and I'm going to create another directory here called domain. This is just a convention of my own, but this directory is meant to hold domain objects. So when we get into it, you'll see we're going to create some aggregates. One aggregate might be a type, or in another aggregate might be type IDs, things like that. And we will essentially, I want to say this. Have those aggregates, those aggregates will be in our domain directory. All right, whatever. I don't want to get too bogged down in that. Let's start out. Our first aggregate is actually going to be types. That's going to be this one here. And let me open up in a new tab an example. I copy. I need to reference some previous code that I wrote because I can never commit this stuff to memory. It's fine. Just give me 2 seconds here, and I'll be back with the example that I'm looking for. All right. Let's go. Let's go. Searching. Okay. 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 All right. So we're going to do this. Def module copilot.universe.types do. Okay, now this is going to be an aggregate. And our aggregate identifier is, let's see. I don't really have one, to be honest. This is kind of a terrible example to start out with, but we'll just call it types ID. And we're going to have type IDs, which is going to be an array of integers. Actually, you know what I kind of want to do? I kind of want to make it a map set. I think that's what we'll do. Let's call this a map, and we'll default it to a map set dot new. Okay. So that'll hold on to all of our type IDs. And we might use that in the future to kind of recognize when new types have been added to the system. Don't worry if this isn't making sense right now. I will explain it in a little bit. And then recorded at, that's going to be date time. We will potentially want to parse that. This is a lot of times some of the default values to use for daytime. Alright, so I'm not going to make it required, but we're going to record it at daytime. If you give it a string, it's going to parse it. It's also going to shift it to UTC, just so we're always comparing against a consistent time zone. And we're going to truncate it down to seconds. You know, we don't care within milliseconds when these things were recorded. Okay. So, this is an aggregate, at least from the data side of things. And basically, I want to keep track of these two pieces of information because one, I want to know when the types have changed, and I want to know how often we're recording them. If we're recording too often, I actually just don't care. I probably, you know, internally only want to keep track of types that were added or removed once every day, right? So if you're telling me that here's the list of types and it's only been 2 minutes since you gave me the last list of types, I'm just gonna say come back to me tomorrow. And then other than that, I want to keep track of the IDs because I want to be able to tell the system, hey, these types were added, these types were removed. If everything is the same as it was yesterday, then I don't really want the system to react in any way. I want it to just know that, okay, if these types, nothing really changed. We don't need to do anything. If new types were added, I do want the system to react because I want it to then go get the type details for each one of those added types. So, great. This is potentially going to be quite a large aggregate. That's totally fine. All right, so our events then is going to be, we might have an event called type added. We'll have a command called record types. We may have another event, but we're gonna have a couple events here. Types recorded. Types added, types removed. So these events are going to tell us when we are recording the types, and then we'll also be able to see when each one was added to our system and when it was removed. Right. Alright, we don't want this. Not types removed. Okay. Great. Let's add some of these events. Events are typically very simple. I'll show you an example of one here. So we're doing types recorded. Copilot's a freaking genius, and so it was able to just figure that out. Now, I don't want to have all the type IDs in here. We're gonna have a separate event per type ID, but we are going to keep track of when this was recorded here. Types ID. All right, this is not supposed to be called identifier. It's supposed to be called aggregate identifier. We get that by not using use aggregate. We want to use commanded event. Which has an aggregate identifier. Okay, so here's a typical event. You know it's an event because it's using use Copilot commanded event, and it needs to specify its aggregate identifier. Here's the first thing that we're gonna start to talk about. So here's our aggregate types. It has identifier types ID. Then we have an event we have our first event for that aggregate, which was types recorded, and it needs an aggregate identifier types ID. You'll notice that they are the same, right? If I what am I looking for? Open and right split. You'll notice, yeah, all right, here's our aggregate and its identifier is types ID. Here's our event, it has an aggregate identifier types ID. That's because events always need to belong to an aggregate. Just know that for now. We'll get into why later. Things will start to click together, but for now, just know types need to belong to an aggregate. And so we need to have a couple of other types here. We're gonna have type added, and so that's also going to be an event. The same aggregate identifier, type added, also belongs to types, and it's going to have a timestamp of when it was added. Let's see here. For events, I just want to parse it, I think. Don't necessarily want to shift and do all of that. Should just be fine. And then we also have another field, type ID. Now, we know that these are integers, so maybe we just let them be integers for now. I think that's fine. Yeah, I think that's fine. And our removed it's going to be very similar to added, just in the opposite direction, right? Great. All right, so we have this command. We need to define this. See if GitHub Copilot can figure this out. All right, so GitHub Universe. I'm gonna not. Oops. All right, I'm going to not put it in this sub module. I am breaking a little bit the rule that module names are named after the full directory path. It's gonna be fine, but this does just make life a little bit easier. We'll see why later. All right, So it is a command. The aggregate identifier is types ID. And the type IDs is going to be an array of integers. Array of integer, and we'll default it to empty. That's fine. Recorded at, date, time, parse true, shift, 20 seconds. Man, I swear, GitHub Copilot is getting scary good. Scary good. Hold on, I haven't checked chat in forever. Just nothing to check. No problem. No problem. All right. Next step. We have our command. Now we need a handler for it. I'm going to put that in the same directory here. And I'm going to call it record types dot handler. We may want some sort of reusable thing for this. Maybe. All right. This is starting to get to why I was saying it's easier to just have all these things in the same package, because you need to alias a bunch of stuff then. Aliasing basically allows you to refer to the other modules without having to type their full name. This is their full name. If you don't want to type Copilot Universe every single time, you can alias it, and then you can just type types. So I'm gonna do that so that I can pull in the aggregate. I'm gonna do that so I can pull in the command. Then I'm gonna want types recorded. I'll do this part in alphabetical order. Type added, type removed. Okay. Oops. All right. This is not correct. This is not correct. The handle function takes two arguments. Takes the aggregate and it takes the command. And so we're going to make sure that they are the types that we expect. That's what this syntax is. So types equals aggregate. The equal function in Elixir is not what you'd expect. It doesn't do assignment. It does pattern matching. So it's saying that the thing on the right, the variable on the right, matches the pattern defined on the left. So this is a pattern. And in particular, what this pattern is saying is that the thing on the right is a types struct. So it is one of these, an instance of those. And this is saying this command, the value of this variable called command, is a record types struct. So it is one of these. Okay. So if this function gets called, it means that the command is a record types command and the aggregate is a types aggregate. That is how Elixir pattern matching works. And we'll get into in a minute why that is so powerful. But for the moment, because we have this aggregate here, and it's a Copilot command attack. Sorry, actually, no, I don't want to be looking at the aggregate. I want to be looking at the command. Because we have this Copilot command, and if we go look at that, we can see some of the stuff that it does. One of the things that it does is use zstruct. Because of that, we get a handy little function on here. Oops. Called validate. So we can do record types dot validate, and then instead of calling this, whoa, where is my mouse? All right. Instead of calling this command, I'm gonna call it input. I don't want to call it a command before it's been validated. Okay. I'm gonna validate this, and then I'm going to pipe it into a case statement. All right. And what that's gonna do is it's going to make sure that the input, whatever it is, actually follows the rules that I'm defining here. So that the type IDs is an array of integers, and the recorded at is a date time. And it's also going to, if it's a string, parse it, shift it to UTC, and truncate the seconds. So all these rules that I'm defining here, they don't get enforced just automatically. You need to call a function like validate in order to enforce them. There's, because Elixir is the way it is, you could easily just create a struct and put invalid data in there. But if you call validate, that invalid data will get checked against the rules, and then you'll get errors. Okay. So if there was an error, we're going to return an error here. Error, invalid, command invalid, and then the errors. Okay, cool. If not, we're going to say, okay. And now we're going to call this our command. That's our command. Great. And the thing that we want to do is maybe say that the types are recorded. Basically what we'll do here is we'll say if it's been more than 24 hours since the last time we recorded, then we'll record it again. If it hasn't been, then we'll ignore it. Okay, and if it has been more than 24 hours, okay, we'll record it, and we'll put in all the items that were added and the items that were removed. So what we want to do here I'm just thinking, there's this thing called a multi in and commanded. I don't know if I want to use it here or not. Let me cook for a minute. Cooking. All right, I think we will use the multi. I'm gonna create a function down here called def, maybe record types, and it's going to take the aggregate and the command. I'm no longer going to enforce this type matching because I don't want to read it every single time, and I'm making this a public function for unit testing purposes, but there's really going to be nothing that calls this besides the unit test potentially. So first thing it's going to do is say if aggregate dot recorded at is equal to nil, or the difference between the date times is more than 24, or yeah, if the difference between aggregate recorded at and this command recorded at is more than 24 hours, we will record. Otherwise, we will simply return okay. I kind of want to do this the other way around and say if it's not equal to nil and let's see, how can I calculate the difference between two dates in Elixir? I don't remember how to do that. That's okay. We'll look it up. We'll look it up. We're getting close to time, but I think we can finish this. Compare diff. So we got two date times, we diff them. All right. Boom. So we're gonna test this out here in a terminal real quick. Date time dot diff. If you don't know what this is called a sigil, and it allows you to create date times without specifying the full struct like that. You can just simply do something like 2023. Today is, it's May 3rd. And It is 10:15 in the morning. That's gonna be our first date time. And I kind of want to just compare it to itself. Make sure we get 0. Invalid format. Yeah. What is the valid format? I can't remember all the time. I'll find it real quick. What is the valid format? Cooking. That's just going to be my new thing. Oh man, I feel like I don't use it anywhere in this project. Okay, hold on. Elixir, date, time, sigil. UTC date time. Oh, I forgot the also important Z at the end. Yes, because it couldn't figure out that it's in UTC, even though this is a UTC sigil. I don't know. Whatever. Oh, it's still not happy about that. Invalid format. What's wrong with my format now? Oh. I forgot the 0 in front of the 3. That's what it was. Okay, well, we'll just use these 2 date times. Alright, so if this one is earlier, say it's on the 30th, okay, then the difference is going to be a big positive number. If it's later, it's going to be negative. Okay, so what that tells us is we need to pass in the command date first and the aggregate date here. So basically, if the command is greater than or if the difference is greater than or equal to that, then we'll do it. If it's less than or equal to that, then we won't record it. Okay. So if aggregate recorded at is not equal to null, and datetime dot diff command dot recorded at aggregate dot recorded at is less than well, put a little constant up here. I'm not gonna do it there. All right. We'll say record interval, and we'll have this be (24) times 60 times 60. Yeah. 24 times 60 times 60. Okay. That's going to be a recording interval. then that is an error. Error, record interval not reached. That's a decent error name. Sure. Okay. Otherwise, now we will consider doing that multi. Let me go back and find the example of how to set that up. So I don't have to look up the documentation, just look at code that I've wrote before. All right, so the multi starts out by piping the aggregate into something called multi-new. We're probably going to need to import that. We'll figure out how to do that in a second. And then we pipe that into some functions. So our first function is going to be called types recorded. It's not a coincidence that this function is named after this event here. This function is going to produce that event. And then we will need to reduce over we will need to do a multi-reduce over the types added. And type removed. I think we will remove types before adding them. I think that sounds right. First, remove all the types, and then add the new types. I think that sounds good. All right, this will not be an execute. This will be a multi-reduce. See if I can find an example of that. Okay, I can't. So we'll come over here to documentation, check out commanded. Multi. Okay, that's kind of what we've got. But we need reduce. The way that you use multi-reduce is you pass in your array of items that you want to reduce over, and then your function. That's going to be an array. That'll be an array. All right, so we need to add these three functions here. Types recorded. We kind of want that, but we don't want to do any of this validation stuff. Just that. def type removed. This is not going to be the aggregate. This is going to be type ID. And so what we will do here is do type removed, just like that. And another function called type added. Okay, so we've got our 3 helper functions here. This actually takes the aggregate in the item. It doesn't take the command. That is important to know. And also totally fine. Okay. Aggregate and item. Do I have to? I don't want to pass in the command. Aggregate and type ID. I think for this one I can just do /2. I don't need to bind the command. I don't need the command. Aggregate item. Yep, should be fine. So what multi does basically is it allows you to emit multiple events from one command, and that's what's going on here. All right, so it's time to summarize this file at a high level. We're defining a command called record type, and that's going to have an array of integers in it, and the recorded at, and then we've defined this handle function, which is going to take an aggregate and the input. So the first thing that we do with the input is we validate it to make sure that our command does indeed have an array of type IDs and that the recorded at time is in UTC and proper date time and all that kind of stuff. Okay. And then we have 2 cases. In the case that it was validated, we have the case that everything's all good and we want to maybe record the types with the aggregate in the command. And we have the case that there was an error, in which case we're going to say error, invalid command, error. So in the case that everything was good and we're maybe going to record the types, first thing we need to do is check here to see, all right, the aggregate recorded at is not equal to null and the date time difference is less than the record interval. If that's the case, then the record interval is not reached. Now, if the recorded at is null, that means we've never recorded before. We definitely want to record. If the recorded at is not null, but the aggregate recorded at time, well, if the command recorded at time is greater than the recorded interval from the aggregate recorded at time, that means that, you know, more than 24 hours has passed in our case, then again we want to record. So recording is going to do many things. It's going to emit this event here saying that it was recorded. We also need to include the types ID like that. All events need types IDs. So that's good. This one is going to need to come from the command. We'll get into why later. Alright, so we're going to say that the types were recorded at this time, and then for each type that was added, or each type that was removed, we're going to remove those, and for each type that was added, we're going to add those. So we need to compute this array here. Removed IDs going to be something like that, and added IDs something like that. Now that's obviously not correct, but the removed IDs are going to be IDs that are in the aggregate that are not in the command. The added IDs are going to be IDs that are in the command that are not in the aggregate. Now the first thing that we need to figure out here is in the aggregate things are a map set. The command things are an array of integers. First thing we need to do is convert that array of integers into a map set. Luckily, pretty sure Elixir gives us a nice way of doing that. If we look at a map set here, we can just do new and pass in our array, and it's gonna just work for us. So command type IDs equals map set new command type IDs. Very cool. We've got that. Now we need to find the difference between them. But we don't just want the difference. Returns a set that map set 1 without the members of map set 2. Okay, so let's just check this out here again in our terminal. So we're gonna do map set that difference of map set new, and we'll say 1, 2. All right, so that first map set's gonna have 2 items, 1 and 2, and our second map set is gonna have 2 items, 2 and 3. All right, so the difference in this direction is going to be 1. And the difference in the other direction is going to be 3. Okay, so things in the aggregate that are not in the command is going to be the delete items. Things in the command that are not in the aggregate, it's going to be the added item. That's how we're going to do that. Things in the aggregate that are not in the command map set dot difference aggregate dot type IDs command type IDs this is going to be the same thing, just the other way around. So looking at our terminal, this is giving us things that are in the first set that are not in the second set. So here we've got things that are in the aggregate that are not in the command. Those are the removed. Things that are in the command that are not in the aggregate. Those are the added IDs. That's exactly what we want. All right, so now that gives us back a new map set though. We then want to convert that to a list. So luckily we have this map set to list function that's able to do that for us. And so we will simply type that into map set dot to list. And now we will have that and that. Some Elixir people probably are screaming about the fact that I am using anchor variables here. To those people, I say I don't care. It's fine. This kind of anchor variable is sort of fine because I really don't want to simply inline this since it makes the code less readable. It's much more readable to say reduce the removed IDs and type, call the function type removed. Yeah. Much more readable that way. Okay, so we have this command all done now. Mix format. We're a little over time. I think we're gonna pause here. A little bit of a cliffhanger. What are we gonna do next time? Next time we join, we are going to connect the two things that we've built. So what do I mean by that? We've built this easy client here. And we have this function get types. We're going to call this, which is going to give us back an array of IDs. And then we're going to take that and we're going to dispatch this command, which is going to get handled, validated, record the events. So it's going to record many events. This one, types recorded, as well as all the typed removed and typed added things. Now there's a little bit of plumbing that needs to go on here, which is why we're going to need to pause here. But next time we're going to get this type data imported into our database. We're going to take a look at it. Then we will talk about how we're going to get the type details for all of these things. Cool. That's going to be it. Oh, hey, Clarky. How's it going? What is EVE Copilot? Sick. Glad you asked. Sorry if it took me a minute to see your comment. I was a little bit in the weeds there. What EVE Copilot is it's going to be a tool that uses React Flow, and actually more specifically a library built on top of React Flow called Data Blocks. And the idea here is that the backend is just going to supply raw data to you as the user, and the front end will be this data blocks application. If you look at a demo, the way data blocks works is you start out with input data, then you can transform it and visualize it. So let's start out with some example input data, and we're going to look at UFO sightings here to keep it space themed. We could theoretically filter out certain things. So let's say we want to filter year number is greater than 1970. Oops, 1970. Okay, so we're going to run that. We're going to see this data now is from 1971 onward. Let's do 1969. Actually, hold on. We're going to, instead of say greater than, we're going to say greater than or equal to 1970. This is not the point. I just want to show filtering. Okay. And then we were able to transform our raw data. Now we can plug it into a time series. And visualize it. So we can now visualize all the UFO sightings from 1970 onward per year. So we can see that there weren't many, and then in the mid 90s or late 90s, mid 90s, we started to see more UFOs, and now not so much. So EVE Copilot supplies raw data. Think of it as market data, solar system data, whatever it is, and then provides you with this visual editor to be able to process that data. So EVE is constantly called spreadsheets online because everybody makes custom spreadsheets. The idea here is to be able to create data blocks to process, the EVE data that we're already doing. But the cool thing about it is if you create this data block, in this case, a custom visualization, you can save that and then share it with other people. So think about what Oz does. He's got a spreadsheet for trading that he shares around. Now, that's fine, but you got to copy it. You need to learn how that spreadsheet works. And, if there are updates to the formulas, you need to, I guess, just copy a new spreadsheet and start over. The idea here is the data block is going to be something that is shareable to other people, and the maintainer of that data block can update it, and everybody will sort of get those updates. If you want to make changes to it, you can fork it and make your own custom edits to it, and it's really a way for you to build powerful data exploration tools on top of EVE's custom data. Now, if there's a data block that you want that doesn't just come out of that we don't come out of the box with, there will also be a custom code block so that you can process the data in basically any way that you can imagine. So that's it. I gotta run for today. I'll be on tomorrow, same time. I'll set up the stream schedule soon. Hopefully see you around, Clarky. Thanks for tuning in. Bye.